Good afternoon, class. Today we're going to talk about solving quadratic equations or functions using the quadratic formula. The quadratic formula is given to you here. X equals negative b plus or minus the square root of b squared minus 4ac. If you recognize this from the other night, it's the discriminant all over 2a. Yes, you're going to have to commit this to memory. So start memorizing now. The good thing about the quadratic formula is that you can use it to solve any quadratic equation or function, but it's mostly used when we cannot factor the quadratic equation or function. Up to now we've been able to factor everything we looked at, but this is when you cannot factor, you'll need to use the quadratic formula. And in order for the quadratic formula to work properly, you have to have the quadratic function set equal to 0. Okay, so when you go to start using the quadratic equation, make sure that your function is written in standard form, which is ax squared plus bx plus c, and it's set equal to 0. Okay, you're going to want to identify the a, b, and c values. You're going to want to, next step is to calculate the discriminant. Remember, the discriminant tells us what type of solutions we have, so if it's greater than 0, we have real solutions. If it's a perfect square, we call those rational, and if it's not a perfect square, we call those irrational. If the discriminant is less than 0, we call those imaginary roots. And if it's equal to 0, we have one real solution. And that will be a rational solution. Okay, one thing I need to remind you all also is that we always have two solutions. Because we have a quadratic, our power is 2, so we're going to always have two solutions to a quadratic equations. Okay, so let's work some examples. So our first example is given here as m squared plus 2m minus 48 equals 0. So whenever we're given said to solve a quadratic, the first thing you want to do is check to see if you could factor it. So this is a case. Let's do our little factor. Our m is 1, so I'm going to just put negative 48 here, and then positive 2 here. So I need something to multiply to give me negative 48, but adds to be 2. So my factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So I notice I could probably factor this using these factors. Make this a negative 6, and get x minus 6 times x plus 8. And that factors out, and I would have x equals 6 and x equals negative 8 as my x-intercepts. So I could factor this one out, but I want to walk through this with you with a quadratic formula. So the first thing we need to do is identify our a, b's, and c's. So I have a is 1, a is 2, and c here is negative 48. So now I'm going to calculate my discriminant. Remember, that's b squared minus 4ac. Plug in the values. So I have 2 squared minus 4 times 1 times negative 48. Do the math, and I get that this is equal to 196. Okay, I know that 196 is a perfect square. Square root of 196 is 14. Okay, so now I'm just going to substitute my values back into the quadratic formula. So I have x equals negative b. So b was positive here, so it would be minus 2. Plus or minus, I'm going to go ahead and put 196 here, because that was my discriminant I calculated, all over 2 times 1. Okay, 196 is a perfect square, so I'm going to simplify that, plus or minus the square root of 14, all over 2. So I know that since I had a perfect square, that's going to tell me that I have two real rational roots. So now I'm going to simplify this. I have x equals negative 2 plus 14 divided by 2. And I have x equals negative 2 minus 14 divided by 2. So we're going to simplify this one more step. X equals negative 2 plus 14 is positive 12 divided by 2, so that is 6. And x equals negative 2 minus 14 is negative 16 divided by 2 will be negative 8. So these match my ones from factoring. So what that's telling me is that I'm crossing over here at 6. And negative 8. Those are my x-intercepts. So I know my graph is coming through. And then down here at 0, negative 48 will be my y-intercept. Okay, so let's work through our second example here. So let's again, first thing, let's see if I could factor this. If I wanted to factor, 4 times -1 is -4, and then I want to add 2, give me 4. Factors are 4, 1 and 4, and then 2 and 2. But I need this to be a negative and that to be a positive. So if this was a negative times a positive, there's no way to factor that. So we're going to go ahead and use the quadratic formula. So we just write can't factor, and we're going to solve this. So we have my A is 1, my B is, my A is 4, my B is 4, and my C is -1. Okay, so now I'm going to solve for the discriminant. I have the value of the discriminant here, and I plugged into my values. So then when I calculate this, I get that that is equal to 32. I know 32 is not a perfect square, so I know I'm going to have irrational roots. So let's go ahead and plug it into the quadratic formula. X equals -b, -4 plus or minus the square root of 32 all over 2 times a, which gives me -4 plus or minus the square root of 32 all over 8. So I'm not done yet because I need to see, I see 32, I need to find out if that can be simplified. And I know that it can because we simplified this one a lot before. So this would be the square root of 16 times 2, which would equal to the square root of 16 is 4. So I bring that out for radical 2. So now I'm going to put that back into where it was. So this came from here. So I'm going to put x equals -4 plus or minus 4 square root of 2 all over 8. And we can simplify that because I can see 4, 4, and 8 are all divisible by 4. And I get -1 plus or minus the square root of 2 all over 2. And that's my final answer. I can't simplify it anymore. Okay, so example 3, I'm going to skip even trying to factor. So it says that I just want to practice using the quadratic formula. So I'm identify my A, my B, and my C, set up the discriminant, b squared minus 4ac, and calculate the value. So I have 3 squared minus 4 times 3 times -10, and that is equal to 145. 145 is not a perfect square, but I do some math. I divide it by 5 because it's divisible by 5, and I see that 5 times 29 gives me 145, but neither one of those are perfect squares, and they have do not have any more factors. So I know 145 cannot be reduced. So I'm going to substitute into the quadratic formula. X equals -b. Since b was already negative, I switch it to positive, plus or minus the square root of 145 all over 2 times a, which is x equals 5 plus or minus square root of 145 all over 6. Okay, you can leave it like that, or you can rewrite it as x equals 5 plus 145 all over 6 and 5 minus 145 all over 6, because we have two solutions, because it is a quadratic equation. Okay, and remember, these are irrational roots because this is not a perfect square, and whenever I have a discriminant that's not a perfect square, we call those irrational. So these are two real or rational roots. Okay, the last example I'm going to do today is example 4. Identify my A, my B, and my C. Alright, so the first thing I'm going to do is calculate my discriminant. I plugged in my values, and -12 squared minus 4 times 12 times 5 gives me a -96. So I remember from my discriminant talk that anytime I have a discriminant value less than 96, less than 0, I am going to have imaginary solutions. So I know that if I plug this in, x equals -b, b is negative, will be 12 plus or minus the square root of -96 all over 2 times 12. So I'm going to have x equals 12 plus or minus, I'm going to go ahead and bring my I out for 96 all over 24. So my next step is I need to simplify the square root of 96 and see if that breaks down. Okay, so to remember to break down a radical, you go through your list of perfect squares, and I see that if I divide that 16, we'll go into 96 6 times. So this breaks down to the square root of 16 is 4 radical 6. So I'm going to plug this back in for radical 96, and I get x equals 12 plus or minus 4I radical 6 all over 24. Okay, so now notice that 12, 4, and 24 are all divisible by 4. So I have x equals 12 divided by 4 is 3, I radical 6, and then 24 divided by 4 would be 6. And that is my final answer. So you could leave it like that, or write 3 plus I radical 6 all over 6, and 3 minus I radical 6. Both forms are acceptable, and I know you'll be tempted to divide this 3 and 6 out, but I can't because this is a 1 here, and the 1 is not divisible by 6. So make sure you do the completion ticket that follows the video. Bring any notes or questions that you have to class tomorrow, and have a good night.